Hello all. In the previous video we discussed about the basic LED interfacing using IMAP technique. Now in this video we discuss about the rotate the LED pattern using RRC instruction. So how the rotate, so the LED look like there are 8 LED connected as shown in this diagram. So now each LED is glown at a particular time and then shift and then after shifting the another LED is glowing. So this is known as the rotate by the rotate instruction. So how we'll do that? So first of all we use these any type of connection, either common anode or common cathode, but here we used common cathode type connection, so that's why 8 LEDs are used. So that's why and the method is known as IMAP diode. So our first task is to transfer the value 01 MVI A,01 hexadecimal and then it out to FF port address. Okay, this is a port address, this is a port address, not data, and the accumulated data is 01. So now what is the status of the LED? Because there are 8 LEDs are connected, and that LSB bit of LED equal to 1. Okay, after transfer the 01 to the port address. So after this these LED will be glown. So now there is a delay program. Here we write the delay program. This delay program is same equivalent to this delay program. This code is used here, and here we used call delay program. Delay, this code is called via using call instruction, and after this the status of this bit equal to 0000001, and then you shift this bit in the left hand side. So you used rotate accumulator left through carry, so we used RLC. Okay, so now after this RLC, and one thing should remember, there are 8 bits, so there are basically 8 shifting are required, therefore we count here. This is a count value 8. Okay, so RLC, and after RLC instruction we check if the counter is 0 or not. If the counter is not 0, then again it jump back to yes, right, out FF, and then again call, and this process is repeating. Okay, now this is the process. Okay, so now in a programming there is some changes, but in a delay program this is the same delay programming, but here in the main program there are some changes. The changes is, first of all we write MVI B,08 for 8 counting, 8 step counting, and here mention the value is L3 is used here, because here L2 is used, so that's why here I change here, this is L3 and this is L4. Say this is this is L3 also. Okay, so now see that in a programming. So next one is MVI A,01 hexadecimal, then there is a target of L4. Okay, so then we use out FF hexadecimal and then call delay subroutine, and then we use RLC. Okay, then decrement TCRP. Okay, then check jump if 0 or not. This L1 should be replaced by, what is the value? Yes, L4 should be L4, because this is L4. If jump if no 0, then again come back to here, that means out the port address, and if all processes are done, then you use JMP and goes to the step L3. Now first see the assemble and load, and one thing should remember, in a tools we first open the peripheral devices, and in the peripheral devices here it is point out to the out. Either if it is used as input, then click here, either click, and if it is used as out, so just click in the out. So there are 2 radio buttons are used, and when it is on the port address, what is the port address? Yes, right, FF hexadecimal. So now look here, this is a FF hexadecimal. So now see that what is the status of this bit. So now see that the rate of the simulation is extremely ultimate position. So now start. So see that some problem create here. There is a no shifting because there is an error in our programming. So what is the error? We search here MVI B,08 data accumulator left, so that's why out here, and then call delay. So we use step-by-step simulation. So see that after out FF the LED is glowing. Okay, now see that when call delay there is a delay, and see that here A equal to D and then C. After when it is 0, then the return is come back to the main program, subroutine is come back to the main program using return instruction. Now see that now return is come back, now return is executed and it's come back to RLC. After RLC, yes, there is some problem. What is the problem? The accumulator is 0 0, because after this subroutine the accumulator is 0. That's why this is a debugging process to solve the error in a programming. This is very crucial method. Okay students, please follow this. Using debugging method, how can you solve your error? Okay, so now here one modification is needed. What can I do here? First of all, I MVI C,01, we load the number in a C and then transfer the number in the accumulator. Okay, so please follow this method, otherwise it will be there is or say that it is. Now see that this is MVI A01. Okay, this line is okay. Now after RLC the decision is very important, because this is MVI A. So after RLC instruction you should be one instruction is performed here, move. So that is here before this call we can shift it before this call instruction. Okay, but not transfer to the port address. We shift this value in the accumulator and save this value and save this value in register C. Okay, so shift value is register C. Now when call delay and decrement B and call delay program, then the accumulator value is changed due to this delay programming. So now what can I do? So our task is is right, we can change here MVI C,01, then move A, C. Okay, now see that when this decrement is false, then we transfer this program L4 from here to here. Now this is okay. Now this is done, because first C is insert by 01, then it's go to accumulator and then out, then RLC and then save in the register C, and after call delay there is a change in accumulator, so there is a decrement B is false, so that means jump if no 0 is look here. So now the last value C here, updated C is stored here. Okay, is it okay? Yes, right. And then after this yes, there is no problem. Okay, for now see that, and in assemble and load operation, first is a step by step. Okay, now start this, and after simulation process, so that the first LED will be glown, and now second process. Now see that when in the delay there is a delay programming used. Now see that when accumulator is 0, it's come back to the main program. Now see that, yes, now the shift on LED. Okay, so this is the debugging process to solve the error in a programming method. So now see that when I select the simulation rate is very fast. So now see that this is a rotate of LED. Now it changes the delay. There is a changing timing sequence of this shifting of this LED from lower bit to higher bit. Okay, so now this is the process by which we can rotate the LED pattern using IMF tau technique. And student, please remember that after you programming there have some error, so please check your errors and find your errors and to solve it by debugging process. So this is very important for programming. Okay.